Today I will discuss system of linear first order differential equation. Here this topic is depend on applied part. Today I will see what is the actual combination of pure part and applied part. This video is very interesting video. Also this type of question actually very important for CSNA. Every year this type of question has come. First I will see system of linear equation for single variable dx dt equal to alpha x with initial condition xt naught equal to y naught. Obviously here the solution is, we all of us know, after solving this would be the solution would be such type xt equal to c e to the power alpha t, and here the solution depends on initial condition. When c equal to 0, then the solution is trivial solution, and when c greater than 0 and alpha less than 0, then the solution always tends to 0. When c greater than 0 and alpha less than 0, then the solution xt always tends to 0 as t goes to infinity. And when c less than 0 and alpha less than 0, then the solution tends to 0 as t goes to infinity similarly. That means combine these two relations, we can tell absolute value of xt tends to 0 as t goes to infinity if alpha less than 0. And when c greater than 0, alpha greater than 0, then xt tends to infinity as t tends to infinity. And for c greater than 0 and alpha less than 0, also absolute value of xt tends to infinity as t tends to infinity. Therefore, combine these two relations, we can tell absolute value of xt tends to infinity as t tends to infinity when alpha greater than 0. Therefore, the solution is either towards the 0 or away from 0. I hope my all viewers have understood first order linear equation when the variable is single variable. Then I will say when the variable is double variable. Let's see second variable example. Now I will see system of linear equation in two variable. How look like the system of linear equation in two variable? Dx dt equal to alpha x plus beta y and dy dt equal to gamma x plus delta y. We can write this system of linear equation in two variable in matrix form such that ddt of xt equal to axt, where xt equal to, obviously the column variable is xt yt and the matrix A is alpha beta gamma delta. Therefore, we can write the system of linear equation in two variable by matrix form. Now my question, how we can find the solution for system of linear equation? There exists a nice theorem to find the solution of this system of linear equation in two variables, three variables or more variables. Suppose lambda and v be the eigenspace, where lambda is the eigenvalue and v is the eigenvector of the matrix A, then xt equal to e to the power lambda t v is a solution of this differential equation x prime t equal to axt. Why this is solution? Just put this is in this differential equation. X prime t equal to obviously lambda e to the power lambda t v a times, here x t means e to the power lambda t v. Therefore, this imply lambda v into e to the power lambda t equal to a v to the power lambda t. Just omit e to the power lambda t in both sides. Then that imply a v equal to lambda v. And obviously this is the eigenvalue problem, which is actually determinant of a minus lambda equal to 0. That means lambda square minus a plus d lambda plus ad minus bc equal to 0. Since this is the eigenvalue problem, so there can be three possibility. One, distinct real root. Second, complex conjugate root. And third is repeated roots. Now I will say this matrix A equal to 1 0 0 minus 1. Here the eigenvalue are 1 and minus 1. Therefore, the solution would be such type xt yt equal to, since eigenvalue here the 1 and minus 1, and find the eigenvector with respect to eigenvalue this 1, eigenvector would be 1 0, and with respect to minus 1 the eigenvector would be 0 1. So the solution is such type xt yt equal to c1 e to the power t 1 0 plus c2 e to the power minus t 0 1. Then my question, how look like the solution? This is depends on different value of c1 and c2. When c1 equal to 1 and c2 equal to 0, then the solution look like, then xt equal to e to the power t and yt equal to 0. As t goes to infinity, this value is always tends to infinity. And if we consider c1 equal to minus 1, then as t goes to infinity, xt always goes to minus infinity. So this is this solution when c1 equal to 1 or c1 equal to minus 1, this solution would be in this direction. Means when c1 equal to 1 and c2 equal to 0, the solution always would be away from origin. Second, if the initial condition c2 equal to 1 and c1 equal to 0, then the solution would be xt equal to yt equal to e to the power minus t and xt equal to 0. And as t goes to infinity, this value yt always tends to 0. Also, if c2 equal to minus 1, then this value is also tends to 0, but only different direction. Therefore, for c2 equal to 1 and c1 equal to 0, the solution would be in this direction, which is towards origin, but the solution always lies in this vertical line. When c1 equal to 1 and c2 equal to 0, and when c2 equal to 1 and c1 equal to 0, or c1 equal to minus 1 or c2 equal to 0, c2 equal to minus 1 and c1 equal to 0, always the solution lies in the x-axis or y-axis. But how would be the solution when c1, c2 is other different value? This would be such type. Why this is? Because here xt equal to c1 e to the power t and yt equal to c2 e to the power minus t. For this, xt times yt equal to c1 c2, and c1 c2 is actually hyperbola type. For any value of c1 c2 or for any non-trivial value, this would be such type of hyperbola. Solution would be goes to such type. I hope my all viewers have understood how would be solution for this type of second order linear differential equation. Here the eigenvalue is distinct eigenvalue. Now consider this matrix, and here the eigenvalue is 2 minus 2, and with respect to 2 the eigenvector is 3 1, and with respect to minus 2 the eigenvector is 1 and minus 1. Therefore solution look like xt equal to c1 e to the power 2t 3 comma 1 plus c2 e to the power minus 2t 1 comma minus 1. Then how look like the actual picture of the solution? This is my question. c2 equal to 0, then x1t would be 3 e to the power 2t and e to the power 2t. y1t would be e to the power 2t. This solution is possible when c2 equal to 0 and c1 equal to 1. Therefore, for c2 equal to 0, the solution would be such type, since here x1t equal to 3 to the power 2t and y1t equal to e to the power 2t. Therefore, x1t equal to 3y1t, and the solution would be such type. And since here e to the power 2t, so obviously as t goes to infinity, that solution tends to infinity, then the solution would be such type. And when c1 equal to 0 and c2 equal to 1, then x1t equal to e to the power minus 2t and y1t equal to minus e to the power minus 2t. That imply x1t plus y1t equal to 0. Therefore, this is actually x1t plus y1t is equal to 0. Therefore, the solution would be such type. And since here e to the power minus 2 to say, therefore this is goes to 0. Okay, this is the solution, and this solution is when c2 equal to 1 and c1 equal to 0. Other solution, other general solution for arbitrary values of c1 c2, this value would be such type. This is This will be the solution of this system of linear equation. I hope my all viewers have understood this type of solution easily. Okay? Oh well. Now consider matrix A equal to minus 1, 0, 0, minus 2. Here obviously the eigenvalue is minus 1, minus 2. And with respect to the eigenvalue minus 1, the eigenvector is 1, 0. And with respect to the eigenvalue minus 2, the eigenvector is 0, 2, 0, 1. Therefore, the solution would be such type: xt comma yt equal to c1 e to the power minus t 1, 0 plus c2 e to the power minus 2t 0, 1. Therefore, from this expression it implies xt equal to c1 e to the power minus t, yt equal to c2 e to the power minus 2t. And this is this solution would be such type yt equal to alpha x square t, because xt over c1 equal to e to the power minus t and yt over c2 equal to e to the power minus 2t, xt over c1 equal to e to the power minus t and yt over c2 equal to e to the power minus 2t. Square both sides, then this would be x square t over c1 square equal to e to the power minus 2t, and put the value e to the power minus 2t here, then this would be such equal to alpha times x square t. And my question similar to before, how look like the picture? When c1 equal to 1 and c2 equal to 0, then the solution xt equal to e to the power minus t. Obviously, this is when t goes to infinity, this is goes to 0. Therefore, this is the solution. And when c2 equal to 1 and c1 equal to 0, then the solution would be e to the power minus 2t. This is also goes to 0 as t tends to infinity. But for other case, the solution, since here yt equal to alpha square x square t, the solution would be such type. I hope my all viewers have understood how the solution of second order system of linear differential equation. Here, how related pure and applied part. This part is applied part, the how look like the solution. But other basic topic, eigenvalue and eigenvector, this part is actually pure part. Actually, application of pure part is just applied part. I hope my all viewers have understood how pure part involved in applied differential equation. Okay. Our next we will see one question which had come CSR NET exam. The question is, consider a system of linear first order differential equation, and the question is ddt of xt yt equal to xt plus yt minus yt. Then what is the solution space? Here the question, the solution space is spanned by the vector 0 comma e to the power minus t and e to the power t comma 0. Second, the vector e to the power t comma 0 and cos hyperbolic t e to the power minus t. Third, the vector e to the power minus t minus 2 e to the power minus t and the vector sin hyperbolic t e to the power minus t. Fourth, the vector e to the power t comma 0 and the vector e to the power t minus half e to the power minus t e to the power minus t. For this, obviously this is y dash equal to ax dash, where a equal to, since here xt plus yt and minus yt, therefore a equal to 1 1 0 minus 1, and that means the eigenvalue of a is 1 and minus 1, and for the eigenvalue 1, the eigenvector would be, just calculate, 0 1 0 minus 2 xy equal to 0 0, that imply 0 dot x plus y equal to 0 and 0 dot x minus 2y equal to 0, that imply y equal to 0 and x equal to arbitrary. Therefore, if we consider x equal to 1, then the eigenvector would be such type 1 v1 equal to 1 0, and for lambda equal to minus 1, 2 1 0 0 xy is equal to 0 0, that imply 2x plus y equal to 0, that imply y equal to minus 2x. Therefore, V2 equal to 1 minus 2. We all of us know solution space of this solution is such type x dash equal to C1. Here the V1 is 1 0 e to the power lambda t for lambda equal to 1 e to the power t. Here V2 equal to 1 minus 2 C2 1 minus 2 e to the power minus t. And here we have to find the solution space is spanned by this vector. Here that means we have to find the value of C1 C2. First indicate the solution space is spanned by the vector 0 e to the power minus t and e to the power t comma 0. This is cannot possible because notice here V1 equal to e to the power t comma 0. But here 0 comma e to the power minus t. We cannot write this solution space as 0 comma e to the power minus t and e to the power t comma 0. So option 1 is a wrong option. Option 2 indicate e to the power t comma 0 and cos hyperbole t e to the power minus t. This is possible because here e to the power t comma 0 cos hyperbolic t e to the power minus t. We have to find these two vector is combination of these two vector. And we all of us know cos hyperbolic t equal to e to the power t minus e to the power t over 1 over 2. This is the cos hyperbolic t. So we have to find this type from this vector. If we consider C1 equal to half and C2 equal to half, then these imply C1 equal to half and C2 equal to half. E to the power t plus e to the power minus t over 2. And here 0 minus e to the power minus t, here minus 2 e to the power over 2, then this vector would be such type. Obviously this vector is cos hyperbolic t and this vector would be minus e to the power t. Okay, here minus e to the power minus t, but here plus e to the power minus t given. So second option is wrong option for this sign. Option 2 also wrong option. And option 3 imply, notice here the vector e to the power minus t minus 2 e to the power t, and here sine hyperbolic t and e to the power minus t. For this, the vector is combination by e to the power t comma 0 and sine hyperbolic t e to the power minus t. For this, since sine hyperbolic t means e to the power t minus e to the power minus t over 2, here we have to take sine hyperbolic t by combination of these two vectors. Here we have to find this type. For this, since here minus sign, so for this consider C1 equal to half and C2 equal to minus half. Then this imply x equal to half 10 e to the power t minus half 1 minus 2 e to the power minus t. Then that imply e to the power t minus e to the power t over 2. Here this imply plus e to the power t. Obviously this imply sine hyperbolic t e to the power t. We can write this vector as this type. Obviously first vector means this and second vector we can write combination of this type when C1 equal to half and C2 equal to minus half, then this implies sine hyperbolic t to the power minus t. So option 3 also right option. And option 4 indicate e to the power t comma 0 and e to the power t minus half e to the power minus t to the power minus t. For this C1 equal to 1 and C2 equal to minus half, then that imply e to the power t comma 0 and here C2 equal to minus half, that means minus half e to the power minus t and e to the power minus t. That imply e to the power t minus half e to the power minus t e to the power minus t. So C1 equal to 1 and C2 equal to minus half, then we can write this vector as this type. And e to the power t0, this is the first vector. When C1 equal to 1 and C2 equal to 0, then e to the power t comma 0, this is possible. Therefore, option 4 also right option. That means option 1 and option 2 wrong option and option 3 and option 4 are right option. I hope my all viewers have understood the geometry of the solution of second order linear differential equation. This is always depends on the value of C1, C2. The value of C1, C2, the solution space is different type. Actually, the solution space is spanned by these two vectors. And this is this idea from pure part, but application is for applied part. I hope my all viewers have understood this type of question easily. Okay? OL. Today I will stop here. In my next video, I will discuss this type of question again because this type of concept actually very important for higher study. See you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.